Welcome to our video. Today, we're going to learn about an exciting topic in math, derivatives. Whether you're a student, a math enthusiast, or just curious, this lesson is for you. Let's dive in. Why are derivatives important? Derivatives help us understand how things change over time. Think of a car. The derivative of its position is its speed. It tells us how fast the car is moving. The derivative of speed is acceleration. It tells us how quickly the car is speeding up or slowing down. For example, derivatives can show how your car's speed changes as you press the gas pedal. Derivatives are everywhere. A derivative measures how a function changes. In simple terms, it tells us the slope of a curve at any point. For a straight line, the slope is constant. But for a curve, the slope changes at every point. The derivative gives us this slope. We won't be diving deeply into derivatives today. Instead, we'll focus on equipping you with the essential skills to comfortably compute the derivatives required for solving differential equations using our novel method. There are two main ways to write the derivative of y is equal to f of x. Prime notation. Y prime is equal to f prime of x. Leibniz notation. dy over dx is equal to df of x over dx, which represents the rate of change of the variable y with respect to the variable x. We will primarily use prime notation, but it's important to recognize Leibniz notation when you encounter it. If you're enjoying this video so far, don't forget to like it, share it with others, and subscribe to the channel for more videos like this. If you have any questions or thoughts, drop them in the comments below. We'd love to hear from you. Let us start with the derivatives of some common functions. Power rule. If y equals x to the power of n, then y prime equals n times x to the power of n minus 1. Trigonometric functions. If y equals sine of x, then y prime equals cosine of x. If y equals cosine of x, then y prime equals negative sine of x. Exponential function. If y equals e to the power of x, then y prime equals e to the power of x. Logarithmic function. If y equals the natural logarithm of x, then y prime equals 1 divided by x. Assume that u and v are functions of a variable, such as x. The derivative of u is called u prime, and the derivative of v is called v prime. Next, we will explore some important derivative rules, including the product rule, the reciprocal rule, and the chain rule. We will go through each of these rules one by one with examples to help solidify your understanding. The product rule is a key formula in calculus used to find the derivative of the product of two functions. If y equals u times v, then the derivative of y, denoted as y prime, is given by y prime equals u prime times v plus v prime times u. This means we first take the derivative of the first function, multiply it by the second function, and then add the derivative of the second function multiplied by the first function. Suppose y equals x squared times the sine of x. Here, we can think of the function as a product, where u equals x squared, and v equals the sine of x. First, we compute the derivatives of u and v. The derivative of u, written as u prime, is the derivative of x squared, which is 2x. The derivative of v, written as v prime, is the derivative of the sine of x, which is the cosine of x. Next, substitute these derivatives into the product rule formula. Recall that the product rule states the derivative of y, written as y prime, is equal to u prime times v plus v prime times u. Using this formula, we find the derivative of y is 2x times the sine of x plus cosine of x times the x squared. In this rule, we calculate the derivative of a reciprocal function. Let us consider the equation y equals 1 divided by v, where v is a function of x. The derivative of y, denoted as y prime, is equal to negative v prime divided by v squared. Now, let us solve an example. Suppose y equals 1 divided by sine of x. Here, v is sine of x, and the derivative of sine of x is cosine of x. Using the formula, we find that y prime is equal to negative cosine of x divided by sine squared of x. The chain rule helps us find the derivative of composite functions. A composite function is simply a function within another function. Let's write this composite function as y equals v of u, where v is the outer function, and u is the inner function, which itself depends on x. The chain rule states that the derivative of y, denoted y prime, equals the derivative of the inner function, u, multiplied by the derivative of the outer function, v. Let's apply the chain rule to find the derivative of y equals the sine of x squared. First, identify the outer and inner functions. The outer function is the sine of u, and the inner function is u equals x squared. Next, differentiate the inner function u, which gives us 2x. Then, multiply this by the derivative of the outer function, v, which is the cosine of x squared. Therefore, y prime equals 2x times cosine of x squared. Congratulations! You've just learned how to calculate derivatives. But our journey doesn't stop here. In the next video, we'll dive into the fascinating world of integrals, focusing on integrating polynomials. So stay tuned, because learning integrals has never been simpler.